Look up on a clear day, and you'll see a brilliant blue sky stretching above you. But have you ever stopped to wonder, why is the sky blue and not green, red, or purple? The answer takes us on a journey from the surface of our planet all the way out to space, where Earth's thin blue atmosphere wraps around a vibrant world. Sunlight, which looks white to our eyes, is actually made up of all the colors of the rainbow. As this light travels through the blackness of space and enters our atmosphere, something fascinating happens. This is where Rayleigh scattering comes in, a phenomenon that explains not only the blue sky, but also the fiery colors of sunsets. Get ready to discover the science behind the colors above us. Sunlight may look white, but it's actually a blend of all the colors in the visible spectrum: red, orange, yellow, green, blue, indigo, and violet. This mixture creates the familiar white light we see every day. As this beam of white light travels through the vacuum of space, it remains unchanged, pure and uninterrupted, until it reaches the edge of Earth's atmosphere. Earth's atmosphere is a thin, protective layer made up mostly of nitrogen and oxygen molecules, along with tiny particles like dust and water droplets. These microscopic components play a crucial role in how sunlight interacts with our planet. Imagine sunlight streaming into Earth's atmosphere, like a beam of white light entering a room filled with tiny invisible dust particles. As this light encounters the molecules of nitrogen and oxygen, it doesn't just pass straight through, it gets bounced around in all directions. But not all colors of light are treated equally. Think of the colors in sunlight as different-sized balls. The smaller blue and violet balls are much more likely to get knocked off course by the tiny particles, while the larger red and orange balls mostly keep going straight. This is because shorter wavelengths like blue and violet scatter much more easily than longer wavelengths like red. Picture tossing a handful of ping-pong balls and basketballs into a crowded room. The ping-pong balls, like blue light, bounce everywhere, while the basketballs, like red light, move mostly straight ahead. In our sky, the blue light is scattered in all directions, filling the atmosphere with a blue glow. This scattering is what makes the sky look blue from every angle. No matter where you look, some of that scattered blue light is reaching your eyes. Meanwhile, the red and orange light passes through the atmosphere with less scattering, which is why the sky isn't red during the day. The effect is strongest when the sun is high overhead, giving us that brilliant blue dome. To sum up, Rayleigh scattering is the process that explains why our sky is blue. It all comes down to how sunlight interacts with the tiny particles in our atmosphere, and how different colors of light scatter in different ways. On a chart of the electromagnetic spectrum, you can see that blue light has a much shorter wavelength than red, which is why it scatters so much more. As the sun sets and appears low on the horizon, its light must travel through a much thicker layer of Earth's atmosphere than when it is overhead. This longer journey means sunlight encounters far more air molecules and tiny particles, which scatter the shorter blue and violet wavelengths out of our line of sight. With the blue and violet light scattered in all directions and mostly removed, the remaining light that reaches your eyes is made up of the longer wavelengths, reds, oranges, and pinks. That's why sunsets glow with brilliant red and orange hues. The sun's rays have traveled a long path through a thick hazy atmosphere, leaving only the warmest colors for us to see. Let's recap what we've learned. Sunlight is made up of all the colors of the rainbow, but as it enters Earth's atmosphere, it encounters countless tiny particles, mainly nitrogen and oxygen molecules. These particles scatter the incoming sunlight, and thanks to Rayleigh scattering, the shorter blue wavelengths are scattered in all directions, making our sky appear blue. So the next time you look up at the sky, remember, it's the dance between sunlight and atmospheric particles that paints our world in brilliant blue. Thanks for watching. For more fascinating physics explained simply, subscribe to PhysicsAI and hit the like button. Stay curious. If you found this video insightful, please give it a thumbs up and subscribe to PhysicsAI for more deep dives into the science of everyday life.